Now we're going to review here figure 15-11A and B. We have a two-parter here. And the illustration comes from Stallcup's Electrical Design Book, Volume 2. And again, if you folks will, if you like our videos, subscribe and so we can keep bringing these videos to you. We would appreciate your help. Now let's get on into this feeder routed over to this sub panel. And, we get questions, do we need a main in this sub panel? No, you don't. If you look at the exception 1 to 408.36, the main and the service equipment, you do not need another main here. But you could have a non-fusible, or not non-fusible, excuse me, but a non-automatic circuit breaker there just to disconnect everything below it so you wouldn't have to go back to the panel if you wanted to, or you put a main there. It's your choice. But we're going to calculate this feeder based upon 215.2A1 and 215.3. Now, we're not routing it through a higher ambient type temperature, and it's a single phase system. So we don't have, more than 3 current carrying conductors. If you determine which conductors are current carrying. Now, starting with the motors to the left-hand side of the diagram, notice we have a 5 horse and a 5 horse single phase 230 volt. We have 37.5 amp of receptacle loads already demand applied to them, so that we come up with 33.5. Now, 30 amp is the continuous duty appliance per phase. And we have our largest motor. It's a single phase 235 horse, 220.50. And then we have our lighting load. That's a continuous lighting load per phase. Then we have an AC unit at 5 kVA and heat at 10 kW. Now, if we look at the, I believe it's in Article 220, if we reviewed loads that are larger, you could take the larger load here and drop the air conditioner. And then the air conditioner's gone until you figure it as a branch circuit. And then we have single phase motors of 120 volt, 1 horse and 2 horse. And that's what the feeder is supplying over to this sub panel. So let's look at the calculating procedure in the next video.